Like
Okay.
if you're going a really long way, the grade's going to be different. If you're going a short way,
Is it?
Well, that's what I'm trying to
That's a good question. I don't know the answer. Let's learn it together. So, what does a 6% grade mean? Well, it goes back to this. What does 6% mean? What does 6% mean in general? Forget the roads for a
6
second.
out of 100.
It means 6 out of 100, yes?
Yeah.
Let's learn about grade today. Let's learn about grade. Let's learn about grade. Let's figure out what grade is through defining what 6% means. We'll use 6% as an example. 6%. You ever thought about that word percent? Percent. What does cent mean? Cent is a prefix, meaning 100.
Yeah.
Like century, things like that. Centimeter, centigram, things like that. So percent means per 100. 6%, I've been told, I don't know if this is true, that this symbol actually is a breakdown of the number 100 written differently. So 1 and 2 zeros, I have no idea if that's legitimate or not. But it means 6 per 100. So it's 6 out of 100. Well, 6 what out of 100 what? What do you think?
Yeah, degrees.
6 degrees out of 100 degrees? I can't envision 100 degrees. What does 100 degrees look like?
Is it 6 degrees out of 100 feet?
6 degrees out of 100 feet?
I don't know.
That's a good. I have something for you to think about. This doesn't have a unit on it. There's no unit on this. It's 6%, but there's no inches or feet or degrees or anything like that. So whatever unit you use to measure in the top number has to be the same as the unit you measure in the bottom number. So it can't be like feet out of degrees or degrees out of feet or something like that, because they wouldn't cancel. Ryan, what do you think back there?
All right, ask the question again. What is your official question?
What is it? 6 what over 100 what?
For the grade?
Yeah, like what is the 6 and the 100? How does that tie into this road?
I'm pretty sure that's the percentage, because a road can either be straight or vertical. So it
I'm glad there are gradations between that.
Yeah.
A hell of a place to drive this
the
planet.
Percentage is just the difference between horizontal and vertical, right?
But how are we measuring it? Like what is this 6% versus a 10% versus a 12% versus a 15%? Versus a negative 18%, for example. Maybe we're talking about negative 18%.
Well, it's the
Are we
degree
going
of
down 6 feet every 100 feet?
Aha! So now I heard the same unit, feet and feet.
Yeah, so you're
So
going down.
Brittany's got to vote for 6 feet, and she's got to vote for 100 feet. So let's talk about going up the hill, because I'm looking up the hill here, not down the hill. You say going down 6 feet for every 100.
Yeah.
Since I'm looking up the hill, we'll talk about going up 6 feet for every 100. That's exactly what grade is when you measure it on a road. When you look at grade and it gives you a percentage, like it's doing on that sign, the grade is the distance that the road, or whatever you're measuring, rises or falls. I'm going to put rises in quotes because it could also fall. Over the distance the road runs. So in other words, grade is what the rest of the world calls slope. What you guys would have called slope, you talk about slope in mathematics classes. What you guys have been calling slope all along, the rest of the Department of Transportation world calls grade. Okay, grade is the same thing as slope. So if we draw a picture of College Way, which I will do right here. We draw a picture of College Way like this. Okay. That could be exaggerated. We haven't answered the question yet as to what the angle is. If you draw a picture of College Way, where's the rise? Where's the rise? You have to go back to your algebra skills here. Where's the rise in that image? Good, good, good. Where the y-axis would be. Where are you to put an axis in? So if you were to slap an axis between the horizontal and vertical, this guy here is the rise. Where's the run?
x-axis.
The x, parallel to the x-axis. What's this up here?
Slope.
Actually, it's not. The slope's the ratio of the rise and the run.
That's
What's the
line.
third piece?
It's the equation line. Isn't it kind of?
Oh, I like that. That's good. Oh, you're thinking analytically, out of the geometry, Brittany. I like that. Good. Good. If you were breaking it down to just that remember what that part of the triangle's called? Remember this? Remember the word hypotenuse from back in the day? If you don't, we'll come back to it on Wednesday because we've done enough reviewing for one day, I think. Tammy?
Is this the same thing as the Pythagorean theorem?
That's what I want to not bring that up. Yes, it is. But it seems like when I mentioned hypotenuse, people were just like, oh god. So we will hold Pythagoras for next time around. What is this? Where does your car go?
To the road.
On the road. Where's the road? Is it the run?
No.
Is it the rise?
No.
No, it's this. This is where your car sits. And this is probably the most confusing if you drive a 1984 Buick. That's where your car sits. Your car sits on that tilted part. I call it tilted, sort of jokingly. It doesn't have to be tilted. It could be perfectly flat. Or it could be perfectly vertical. Hopefully not. Hopefully we're not building roads that are perfectly vertical. So your car sits on, I like the equation line. It ties it back to what we were doing earlier, Brittany, the equation line. But the grade that you're talking about, when you see those signs, 6%, 7%, 5%, whatever the percent grade is, you don't actually drive on that. You're driving through the result of that. The rise and the run, the ratio is equal to 6 over 100. So one way of thinking of that is, it is 6 feet of rise for every 100 feet of run. So Brittany, we're going to ask your question you asked about 10 minutes ago, maybe 5 minutes ago-ish. If you go out 100 feet right here, you will have gone up 6. So you can tell right now I've drawn this horribly not to scale. Horribly not to scale, yes. 100 feet of run for 6 feet of rise. What if you go out 100 more feet? Right? What if you got 100 more feet? What's that going to be? That's going to be 12 feet, isn't it? Because using our argument from earlier, you've gone 106. That means you'd have to go another 106 again. Or, conversely, just go out the full 200. And you'll have risen 12, which is the same thing as 6 over 100. Was there anything magical about using the unit of feet? 6 feet for every 100 feet. Could we talk about a different unit of measurement?
Well, if the plane was rising, when you do it in miles then?
Probably. You gotta go pretty quick, right? Like a rocket. When a rocket takes off the... You gotta play something. Maybe make it easier. Like you don't count a rocket launching in inches. Or even a car launching in inches, for that matter. Kelly, you were not. You said you use different units. What would you use for cars if you didn't use feet? Would you use miles? Miles? What else could you use? Yards? What else could you use? Inches if you wanted to. What else could you use?
Meters.
Meters. Oh, there we go. First European answer. It usually takes about 5 or 6 to get it in there. Now the reason for that is simple. The reason for that is simple. It is a mathematical reason. If you said this was, let's use a purple left, 6%. If you said it was 6 feet over 100 feet, your practice in mathematics tells you when you have the same thing numerator denominator, things can cancel. So the feet can divide off. And you're left with just 6 over 100, which is what 6% is, 0.06, 6 over 100. That same logic would happen if you did 6 inches over 100 inches. You'd have the exact same argument. The common unit of dimension would cancel. And it doesn't matter what you use. 6 kilometers over 100 meters. Huh? No. That won't work. Because it isn't the same unit, correct? It isn't the same unit. It has to be the same unit. The reason I bring this up is because we're going to analyze this in class. Now that everybody has cell phones with them, there's these really cool apps that you can track elevations with. I'm going to have you guys analyze them on your first, I think your first exam you'll turn in a few weeks. I carried it with me in the back of my jersey on one of these awesome road rides you can do around Central Oregon, and it tracks your elevation along with your horizontal distance. The problem is, when they plot the graph, it looks very, very impressive. Like, whoa, you did that! When you look really carefully at it, it's measuring this in meters and this in miles. Right? So you look at this, you're like, look at the slope, dude, you're a freaking beast! Well, not really. If you actually put the units agreeing with each other, Okay, it's not that beastly anymore. But that's the problem. It always makes me wonder, do mathematicians build these things? Well, sometimes they do, but sometimes as Americans we can miss that kind of point. This is also why, Brittany, we couldn't go like 6 degrees over 100 feet and things like that. Because if you do that, then you won't have that cancellation, which means the 6% has to have a unit attached to it, and I don't want that. Because that sign that we just saw back here doesn't have a unit, it just says 6%. That's all it says. So more on this on Wednesday. Let's get into College Way again on Wednesday, and we'll go outside. We'll take all the stuff outside with us on Wednesday. We'll do some measuring of our own grades. I want to do some more exploration of grade before I set you guys loose, though. So if you want to turn that quiz in, your first in-class quiz, let's make a little pile right here. I think you all should. Counts as 1 as your 10. Yes. If that pissed you off, don't worry. We'll find those equations in context as we go. I don't want to freak you all out. Hopefully I didn't. I think I did. If you want to see manual solutions of any of the equations, we'll stick around. We'll do them real quick. If you want to. I'm not gonna force you to.
I got it.
Not going to force you to. Otherwise, we'll see you on Wednesday. Indeed. Shut this guy down.